What if every memory you have ever trusted was slightly wrong? Not because you are forgetful, but because your brain is actively rewriting the past every single time you remember it. This is not science fiction. This is neuroscience. And what AI is revealing about this process will genuinely change how you see your own mind. Most people think of memory like a video camera. You experience something, your brain records it, and later you press play. That model feels intuitive. It also happens to be completely wrong. Memory is not stored like a file. It is reconstructed from fragments every single time you access it. When you remember something, your brain pulls pieces from different regions. The hippocampus handles the structure. The prefrontal cortex adds context. The amygdala layers an emotion. These parts collaborate to assemble a version of the past. But every assembly is slightly different. Every recall is an act of creation, not retrieval. This is what scientists call reconstructive memory, and it has a real cost. Each reconstruction is vulnerable to distortion. New information sneaks in, emotions shift the tone, details get filled in by logic rather than experience. You are not remembering the past. You are rebuilding a version of it that makes sense right now. Psychologist Elizabeth Loftus spent decades proving this. Her experiments showed that simply asking questions with misleading wording could plant false details into eyewitness memories. In one famous study, participants who watched a car accident on video later remembered broken glass that was never there, just because of how the question was phrased. This is not a rare glitch. It is a feature of how human memory actually functions. The brain prioritizes narrative coherence over factual accuracy. It would rather give you a smooth, believable story than a fragmented and accurate one. That is a design choice. And it has enormous consequences for everything from courtroom testimony to personal identity. Now, here is where things get interesting. Artificial intelligence, specifically large language models and generative neural networks, behaves in ways that are remarkably similar to human reconstructive memory. And studying those systems is teaching neuroscientists things about the brain that would have been very hard to see otherwise. Large language models do not store information like a database. They learn patterns across massive amounts of text, and when you ask them something, they reconstruct an answer from those patterns. They do not retrieve, they generate. Sound familiar? That is almost exactly what your brain does when you remember something. AI models also hallucinate. They confidently produce false information that fits the pattern of the conversation. Researchers noticed this early on and called it confabulation, borrowing a term from neurology. Confabulation in humans happens when the brain fills gaps in memory with plausible fiction, completely unaware that it is doing so. This parallel is not just a metaphor. Researchers at places like DeepMind and MIT have used AI architectures to model and test theories about how memory consolidation works in the sleeping brain. Running simulations with neural networks helps neuroscientists test hypotheses they could not ethically test in humans. AI became a laboratory for the mind. One key insight came from a class of AI models called Hopfield networks, updated by Jeffrey Hinton and colleagues. These networks store memories as energy states, and they retrieve the closest matching pattern when given a partial input. That is essentially what your brain does when a smell triggers a memory. Pattern completion from fragments. So AI is not just mimicking intelligence, it is accidentally mimicking human memory. And that accident is giving us a mirror. When we study why AI gets things wrong, we get new clues about why humans do too. The errors are different in scale, but the underlying architecture is surprisingly similar. If memory reconstruction is the daytime version of this story, dreams are the nighttime version. Sleep is not rest in a passive sense. It is one of the most cognitively active processes the brain runs. And a huge part of what it does during sleep is sort, edit, and consolidate the memories from that day. During REM sleep, the hippocampus replays the day's events, but not in order and not completely. It replays fragments, and the cortex integrates them into long-term patterns. Neuroscientist Matthew Walker calls this the overnight therapy effect. Sleep does not just store memories, it strips the emotional charge from them, making them easier to handle later. Dreams themselves appear to be a byproduct of this replay process. As the brain rapidly shuffles and tests memory fragments, some of them bubble into conscious awareness in distorted narrative form. You are not watching a movie. You are watching the brain run stress tests on its own memory library. AI researchers have used a similar process to improve model training. It is called called replay or experience replay, borrowed directly from neuroscience. During training, an AI model randomly revisits past examples to reinforce useful patterns and prevent forgetting recent ones. This technique, called catastrophic forgetting prevention, mirrors exactly what the sleeping brain is doing. The philosophical layer here is hard to ignore. If your memories are reconstructed and your dreams are reconstructions of reconstructions, what is the self that persists through all of this? You are not a fixed recording. You are a dynamic, constantly updated model of yourself. That model changes every night while you sleep. Some philosophers argue this makes personal identity a kind of ongoing narrative, not a fixed essence. Neuroscientist Antonio Damasio suggests the self is itself a memory construct, rebuilt moment to moment by the brain. If that sounds unsettling, it should. But it also means you're more adaptable than you think. So, what do we actually do with all of this? If memory is reconstructive and AI is helping us see exactly how unreliable that process is, the first practical insight is this: stop trusting your memory as ground truth. That does not mean distrust everything. It means hold your memories lightly and stay open to correction. A book worth reading here is The Memory Illusion by Dr. Julia Shaw, a forensic psychologist who studies false memory. She shows that highly confident, emotionally vivid memories can be entirely fabricated by the brain. The stronger the emotional weight of a memory, the more the brain tends to embellish it over time. AI tools are also starting to help individuals work with memory more consciously. Apps that prompt daily journaling with structured questions use a technique grounded in encoding specificity theory. Writing down experiences right after they happen creates a more stable trace before reconstruction distorts them. It is not perfect, but it is significantly better than nothing. Therapeutically, the reconstructive nature of memory is actually hopeful. If memories can be distorted in harmful ways, they can also be gently reframed in healing ones. Therapies like EMDR and cognitive reappraisal work precisely because they target the reconsolidation window, the brief moment when a recalled memory is vulnerable to change. And here's the big picture. Studying AI has not made the human brain seem more mechanical. It has done the opposite. The more we see how AI struggles to do what brains do effortlessly, the more we appreciate the staggering complexity under the hood. Memory is not a bug or a limitation. It is a flexible, creative, survival-oriented system. The brain rewrites your memories because the present always matters more than the past. You do not need a perfect archive. You need a useful one. And every time you sleep, dream, and wake up, your brain is doing exactly that, quietly editing the story of who you are so that you can keep moving forward. Memory is not the truth. It is your brain's best current guess. And now, so is AI. If this video made you think twice about something you were certain of, that is exactly the point. Subscribe for more content at the edge of neuroscience and technology, and drop a comment below. What is one memory you now wonder about?